We are moving on now with applications of linear equations. This whole section is just going to be taking word problems, trying to come up with a linear equation or an equation to model that word problem, and then solving for the missing values. So some strategies for solving word problems. First thing, read the problem carefully, several times if you need to, until you can state the problem in your own words, what is given, and what the problem is looking for. Don't just read the problem once and then say, I don't know what it's asking for, I don't know what it wants, or just read it once and be like, oh, I got this, and move on. Okay? Take your time, read these problems multiple times so that you can restate exactly what it is that the problem wants. If you have any unknown values, let X represent one of those unknown quantities for the problem. The second thing you can do, step 2, if necessary, write expressions for any other unknown quantities in the problem in terms of X. So this is where we're going to actually create an equation for our problem. 3, write that equation to model the verbal condition. So step 3 is kind of making sure that our equation that we've written matches the verbal conditions that we've been given. 4, solve the equation and answer the problem's original question. And then 5, check the solution with the original working of the problem, not the equation that you obtained in steps 2 and 3. And then here I have some helpful keywords that you can look for in the problems that'll help you figure out how to form the equation. So words that mean addition include sum, more than, increased by. Words for subtraction are minus, decreased by, subtracted from, difference between, less than, and fewer than. Multiplication can be indicated by times, product of, percent of a number, multiplied by, twice, and division is indicated by divided by, quotient, and reciprocal. So the rest of this section is just going to be examples of the types of problems you might see. These may not necessarily be exactly what you're going to be seeing as you work through homework and other assignments, but this should give you a good idea about how to approach these types of problems, give you some strategies, and give you an idea on what you should be doing as you work through these problems. So the first example, I have a new car that is worth $45,000 and it is depreciating in value by $5,000 per year. After how many years will the car's value be $10,000? So the current value, the new value of the car is $45,000. So I'm going to underline that because that's an important number. It is depreciating in value. So depreciating means decreasing. So if your car is depreciating in value, that means the value of the car is going down by $5,000 every year. After how many years will the car's value be $10,000? So how many years will the value be $10,000? So my unknown, the thing that I'm trying to find, is how many years. So that's what I'm going to call X. After how many years will the value be $10,000? That's my unknown. So I know that the value is starting at 45,000. If it's depreciating, that means it's decreasing. So we're subtracting $5,000 per year. So every year. So if 1 year goes by, we've lost $5,000. If 2 years go by, we've lost $10,000. 3 years, $15,000. So it's $5,000 for every year, and X represents the number of years that have gone by. So it's going to be minus 5,000x. This expression gives me the value of the car. After X years. So it started at 45,000 and we're subtracting off $5,000 for every year that goes by, and the year is represented by the X. So this expression here represents the value, so I want to know when is that value going to be equal to 10,000. So I have 10,000 equals 45,000 minus 5,000x. So I'm going to solve for the unknown variable. First, I need to get the unknown variable by itself. So I'm going to subtract 45,000 from each side. That way I get all of the constants on one side and all of the variable terms on the other. So this becomes negative 35,000 equals negative 5,000x. Don't forget we had this subtraction here, so we still have to bring down the minus sign. And then to get the x by itself, I'm going to divide both sides by 5,000. I'm sorry, negative 5,000. Don't forget that it's negative, like I almost did. So negative 35,000 divided by negative 5,000 gives us 7, and that equals x. So then we want to answer this question in terms of the original problem. So that would be 7 years. And that is what I would give for my answer. I don't need to elaborate any further, just 7 years. Okay, and we could check this. It would take a minute to check it, but if I start at 45,000 and I subtract 5,000 7 times, I do in fact end up with 10,000. So I didn't use the equation I came up with. I went back to the original wording and I said, okay, 45,000, I'm losing 5,000 every year. My answer was 7, so if I do 45,000 minus 5,000, and I do that 7 times to represent the 7 years, do I get the answer of 10,000? If I didn't get 10,000, then that would mean that my answer of 7 years was incorrect. But I did get 10,000, so that's how I know that my answer is correct. That's how I checked it. I didn't use my equation. I went back to the original wording, and I did the, quote, long method. So there is one example of looking at a word problem, creating a formula, an equation for it, and then coming up with our answer. So a second problem. Superior Cable Television charges $95 for an installation fee and $125 per month for their Star plan. How much would 18 months of service cost? And then we also want to know if the cable television company hopes to make $3,095 per customer, what is the length of time each customer would need to have the service? So, important pieces of information. They're going to charge everybody $95 to install the cable box and all the wires and do all that fun stuff. And then $125 per month for this Star plan. So if you decide to sign up for this service, you're going to pay $95 for the installation plus $125 every month that you have the Star plan. And in this case, M stands for months. I could have also stuck with X, but I think it's a little bit easier if I have the letter represent the thing that it's representing instead of always doing X. And this represents the cost. So $95 is what you're going to pay up front, plus $125 per month. That's the overall cost of this plan. So how much would 18 months of service cost? So we're going to have the $95 plus $125 times 18 months. So that gives us a cost of $2,345. So in this case, they gave us the months and were asking us to find the cost. Now in the second one, the cable television company hopes to make $3,095 per customer. What is the length of time each customer would need to have the service? So now we know what the cost per customer needs to be. What we don't know is the length of time or the number of months they need to have the service. So the cost needs to be $3,095. But we don't know how many months it's going to take to get to that cost. So I need to solve for M. So I'm going to start by subtracting 95 because I want to get rid of this numerical term. So I have 3,000 on this side and 125M on this side. Divide both sides by 125. And I get M equals 24. So that answer is 24 months. Try that, drawing that box again. 24 months. Moving on to the third example. After a 20% reduction, you purchase a television for $336. What was the television's price before the reduction? So we have a 20% reduction or a 20% discount. And we purchased the TV for $336. So what was the price before the reduction? So if we think back to our discount formula from before, sorry, we know that the discount amount is equal to the discount rate times the price, and then we find the purchase price, so the amount that we actually pay, by taking the price of the item minus the discount amount. So what I'm going to do is I'm going to take these two formulas and I'm going to combine them into one. I'm going to replace the discount amount here with this formula here. And the value that I don't know is the price. So X is going to represent the price. So the purchase price, which we do know, so let me cross that out. Our purchase price was $336. The price before the discount, before the reduction, we don't know what that was. Minus, we had a 20% reduction. We can't do math with percentages, so I have to turn that into the decimal equivalent, which is 0.2. So the discount rate is 0.2 times the price, which I still don't know. So that's times X. So here's the price that I put here. And then the discount amount is found by taking the discount rate of 20% times the price, which is X. So then if I put a 1 here, because when we see just an X, we always want to remember that that's 1X. I have 1X minus 0.2X, so that leaves me with 0.8X. When we have an X minus an X and there are numbers in front of them, you look at the numbers and you subtract those and you leave the X's alone. So it's like looking at, if I have one apple and I eat 0.2 of my apple, how much of my apple do I have left? Well, I would have 0.8 of the apple remaining. And then I can go ahead and divide both sides by 0.8 so that I can get the X by itself. And that gives me 420. So the answer is $420 was the purchase price before the discount. We can ask ourselves if this answer makes sense. So this answer of $420 is supposed to be the price before the reduction, before the 20% discount. 420 is bigger than 336. So at least on that point, that makes sense. If my answer was smaller than 336, something would be wrong. Because my answer is supposed to be the price before the discount. So it needs to be bigger. That's one quick way that you can ask yourself, well, does this answer even make sense? This is 420 is before the discount. So it should be bigger than 336. Is it? Yes, it is. Continuing on, example 4. The bus fare in a city is $1.50. People who use the bus have the option of purchasing a monthly coupon book for $27. With the coupon book, the fare is reduced to 50 cents. Determine the number of times in a month the bus must be used so that the total monthly cost without the coupon book is the same as the total monthly cost with the coupon book. So we're going to have to write 2 different formulas for this one. We're going to need to look at how much would it cost without the coupon book versus with the coupon book. So without the coupon book, it costs $1.50 per trip on the bus. With the coupon book, first you have to purchase the coupon book. So that's $27. Then you still have to pay for the bus each time you ride it, but you get a discount. So now you're only paying 50 cents per trip. So each of these have a variable of per trip. So I'm going to say that X is going to represent, I'm going to word this differently. X is going to represent the number of trips. And then what do they want to know? Determine the number of times in a month the bus must be used so that the total monthly cost is the same for the 2 options. So looking at when are they the same, we're going to set these 2 equations equal to one another. So $1.50x equals 27 plus 0.5x. So now instead of subtracting 27 like I've been doing, I'm going to subtract the 0.5x because I have a term with an x on both sides. So that gets rid of the term with the x on that side, and I'm left with 1x over here equals 27. 1.00x is the same as just x equals 27. So that's our answer. So it would take 27 trips for them to be the same price. If you're going to ride the bus 26 times, it's going to be better for you to go without the coupon book. If you're going to ride 28 times, then the coupon book is worth it. If you're going to ride the bus 27 times, it doesn't matter because the price in the end is the same. Example 5 is very similar, but it's a little bit trickier because it's a little bit more wordy. Example 5, you are choosing between 2 plans at a discount warehouse. So think like Costco or Sam's Club, place like that. Plan A offers an annual membership fee of $110 and you pay 80% of the manufacturer's recommended list price. Plan B offers an annual membership fee of $30 and you pay 90% of the manufacturer's recommended list price. So you have how much you're going to pay up front, and then the difference is basically how much of a discount are you getting. With Plan A, you're essentially getting a 20% discount. You're only paying 80% of whatever the price is listed on the merchandise. With Plan B, you're paying a lot less up front, but you pay more overall on the list price of all of the merchandise. So how many dollars of merchandise would you have to purchase in a year to pay the same amount under both plans? What would be the cost for each plan? So Plan A, their membership fee is $110, and you're paying 80% of the list price. Plan B, their membership fee is $30, and you're paying 90% of that list price. So we want to know how many dollars of merchandise would you have to purchase in a year to pay the same amount. So again, we're looking at when are they the same, so we're going to be setting things equal to one another. And then what would be the cost for each plan? And since they're going to be the same, the cost for the plan should be the same. So Plan A, your membership fee is an upfront fee of $110, and then you pay an additional 80%, which is 0.8 times however much money you spend on things from that store that year. So times X. Plan B, you pay $30 up front, but then you pay 90% or 0.9 of whatever it is that you spend on merchandise that year. So X equals money spent on merchandise. So we want to know, when are these two plans going to be equal? So just like I did last time, I'm going to set the two equations that I just wrote equal to one another. And now this one has even more work involved with it, because I have constant terms on both sides and I have variable terms on both sides. So I have to do more work. It doesn't really matter how I decide to move these things around, but one of the things that I see is if I move the 30, if I get rid of the 30 on this side, I still am working with a positive number here. And I like to stay in the world of positive numbers. So 110 minus 30 is 80. So 80 plus 0.8x equals, that should be a plus, 0.9x. And then I can subtract 0.8x from both sides. So this goes away, and I still get to stay in the world of positive numbers. 0.9 minus 0.8 leaves me with 0.1x. So divide both sides by 0.1 so that I get the x by itself, And the answer is $800. You would have to spend $800 on merchandise in order for the plans to be the same. How much would they cost? Well, this is how we'll check and make sure we did this correctly. If I plug in 800 for X, times 800, 750. So under plan A, if you buy $800 worth of stuff, in the end, with your membership fee and your discount, you're only paying $750. Plan B, you paid $30 up front, but you're paying 90% of that $800. So 30 plus 0.9 times 800, and that is also $750. So the plan would cost $750. So on both of these, they become equal at $800, and the overall cost for those two plans is $750. So these two plans save you about $50 once you've spent $800. If you're going to spend more than $800, then you're better off going with plan A because you're going to get more savings beyond that $800. If you're going to spend less than $800, then you should stick with plan B because the lower upfront cost is going to save you in the long run. And you can check things out, plug in different numbers, and make sure that what I just said is correct. But that's how that one is. So one more example of a possible type of word problem you could run into. This one is really tricky. This would be the type of problem that I would say you would expect to see more as like a bonus question. I would not expect you to see something quite this hard as a normal question on an assignment. But it is still good to know how to do something like this. So the average yearly salary of an American whose final degree is a master's is $49,000 less than twice that of an American whose final degree is a bachelor's. I'm going to stop reading right there because there's a lot in that first sentence. So the average yearly salary of an American whose final degree is a master's, so we're looking at somebody with a master's, is $49,000 less than twice that of an American whose final degree is a bachelor's. So a person with a master's degree, their salary is based on whatever the person with the bachelor's degree makes. Because you take twice what a person with a bachelor's degree makes, and a person with a master's makes $49,000 less than that. Combined, two people with each of these educational attainments earns $116,000. So combined, two people with each of these attainments earns $116,000. Find the average yearly salary of Americans with each of these final degrees. So find the salary each of these final degrees. So this problem is one that I like to solve by drawing a picture, personally. I will draw just a little stick figure, and I will say, okay, this is the person with the master's degree, and this is the person with the bachelor's degree. It just helps me visualize what's happening here. So the bachelor's degree, I didn't really get a lot of information about it. All I know is that the person with the master's degree, their salary is dependent on what that person makes. It's based on it. So a bachelor makes X amount of money. A person with a master's degree makes $49,000 less than twice that of a person with a bachelor's. So you take twice what a bachelor makes, and the person with a master's makes $49,000 less than that. So this equation here represents what a person with a master's degree makes. 2x minus 49. A person with a bachelor's degree makes X amount of money. Combined, so if I add these together, they make $116,000. And this is our formula. And it's complicated to get to. So I'm going to rewrite it. 2x minus 49 plus x equals 116. Well, notice I have 2x plus another x. So I have 3x minus 49 equals 116. I'm going to add the 49 to both sides. And then I get 3x equals 165. So x equals 55. So x represented what a bachelor's made. So the bachelor's makes 55,000. But I still need to figure out how much a person with a master's degree makes. Because the master's degree formula, this guy, I couldn't find that until I found the bachelor's. So 2x minus 49 equals my unknown amount. But now I know that a person with a bachelor's makes 55,000. So 2 times 55 minus 49, this is 110 minus 49 is 61. So a person with a master's degree makes an average of 61,000 a year. And that is the answer for finding the average yearly salary of the Americans with each of these final degrees. Not just the bachelor's, that would just be solving for X, but then using that X back in the formula we came up with for the master's to find what their salary is. And these are just some types of word problems you could see. I really like underlining things as I go, as you can tell, breaking things down, reading through the problems a lot. Just take your time with these and try your best to come up with an equation for them as you work through them, and you should be okay.